Hello folks, my name is Michael Martinez and today we are going to discuss about gravimetric analysis and the steps for gravimetric analysis. So first, what is gravimetric analysis? Gravimetric analysis is a technique through which the amount of analyte can be determined through the measurement of mass. Gravimetric analysis depend on comparing masses of two compounds containing the analyte. The principle behind gravimetric analysis is that the mass of an ion in a pure compound can be determined and then used to find the mass percent of the same ion in a known quantity of an impure compound. So now, let's proceed to the steps in gravimetric analysis. Let's go! So now we have these steps for gravimetric analysis. So first we have sample dilution. Second we have precipitation. Third we have digestion. Fourth we have filtration and washing of precipitate. And fifth we have drying of precipitate. Sixth we have weighing of precipitate and data calculation. So first we need to dissolve a sample after weighing. Second is a precipitating agent with excess amount is added to the solution. Third, the result of precipitation is filtered, dried, and weighed. Fourth is determine the amount of the original ion from the mass of the precipitation or precipitate of composition, or also known as composition. Lastly is we need to calculate or we need to have a data collection which we are going to use the stoichiometry as an important chemical equation for gravimetric analysis. Now let's discuss for the types of precipitating agent. So we have two types of precipitating agent. So we have selective, which means react with a few analytes. So we have this example. Second, we have specific, which means react with one analyte only. So selective and specific is the types of precipitating agent.
Good day everyone, I am Christine Aloy and my first topic is all about mechanism of precipitation. So there are two competing processes in crystal formation. The first process we have the nucleation. It occurs when a small number of ions, atoms, molecules initially unite. So there are two. We have the spontaneous and the induced. Spontaneous nucleation will occur on its own, while the induced requires a seed particle to get things started, like dust, another crystals, or glass fragments. So the second process is we have the particle growth, the three-dimensional growth of a particle nucleus into a large crystals. When a nucleation site has formed, another ions are attracted to the site. This will result in the formation of large filterable particles if done properly. So it also reduces contaminates since they don't fit in the crystal structure. So we have some control on particle size based on how we add our reagents. So relative supersession, or the RSS is equal to Q minus S over Q, where Q is the concentration of solution at any time, while the S is the equilibrium solubility of solute. RSS can be estimate or control the type of precipitate that is formed. The goal is to form crystalline precipitates. This can be done by increasing S, which is to elevate temperature, decrease Q, use dilute solutions, slowly add reagents, and stirring the solutions. So next topic we have is the ways to minimize impurities. So in order to have a low solubility, a precipitate must be free from impurities. So one common impurity is what we call the inclusions. Since it is very difficult to remove because it is chemically part of the precipitate lattice, the only way to remove inclusion is what we call reprecipitation. So in which we isolate the precipitate from its supernatant solution, dissolve the precipitate by heating in a small portion of a suitable solvent, and then reform the precipitation by allowing the solution to cool. So let's take an example. Suppose that 10% of an interferent forms an inclusion during each precipitation. When we initially form the precipitate, 10% of the original interferent is present as an inclusion. After the first reprecipitation, 10% of the included interferent remains, which is 1% of the original interferent. A second reprecipitation decreases the interferent to 0.1% of the original amount. So second impurities is what we call the occlusion, from when an interfering ions is trapped within the growing precipitate. We can minimize an occlusion by maintaining the precipitate in equilibrium with its supernatant solution for an extended time. The third type of impurity is surface adsorbates. We can minimize it by increasing the precipitate's available surface area. So the last is we have the interferent, and we can minimize it by controlling solution's conditions, remove its bifiltration, and learning the analyte behind the solution.
Oh, thank you, Miss Christine. Now let us move on to 5.5 gravimetric calculations. We have the different calculations or formulas to be used depends on what is asked in a given problem. We have the formula if the amount of analyte is being asked. We have also the formula in finding the percentage of analyte in a given sample, and the formula in finding the percent by mass of analyte in a sample. So now we have a sample problem in calculating the amount of analyte in a sample. Calculate the amount of boric acid from borax. We have to balance the equation. Next is calculate the molar mass of analyte and precipitate. Lastly is the final calculation wherein gravimetric factor is equals to the moles of analyte over precipitate multiplied by the molar mass of analyte over molar mass of precipitate. So the answer will be 0.648 grams of boric acid. Now let's proceed to 5.6, volatilization and particulate. Volatilization is thermally or chemically decompose the sample and measure the resulting change in its mass. We have thermogravimetry, which is a process that monitors the sample mass as a function of temperature. This shows a typical thermogram in which each change in mass represents the loss of a volatile product. The equipment and volatilization depends on the method of analysis, either simple or complex. This is the instrument for conducting thermogravimetric analysis, which is the electromagnetic balance. Volatilization gravimetric methods continue to play an important role in chemical analysis, like in organic analysis and organic analysis. Volatilization gravimetric methods are time and labor intensive. Equipment are needs few except when combustion gases must be trapped. On the other hand, in particulate gravimetry, we simply need a method for collecting the particles and a balance for measuring the mass. There are two methods for separating a particulate analyte. First is filtration, in which we separate solid particulates from their gas, liquid, or solid matrix. Second is extraction, that is useful for gas particles, solutes, and solids. Particulate gravimetry is important in the environment analysis of waters, air, and soil samples. The analysis for suspended solids in water samples for example, is accomplished by filtering an appropriate volume of a well-mixed sample through a glass fiber and drying the filter to constant weight of 103 to 105 degrees Celsius. Consequently, particulate gravimetry is easily extended to the analysis of trace level analytes. Particulate gravimetry uses the same balances as other gravimetric methods and is capable of achieving similar levels of accuracy and precision.